Lecture 11, Pressure Conduct Part 2. This example determine the elevation of hydraulic and energy gate line at the point A and B, C, D, E. Okay. For the pressure pipes, the energy gate line and hydraulic gate line is similar to, compared to the open channel flow. We draw the water surface profile in an open channel flow, but in terms of the pressure flow, we have to sketch and draw the hydraulic gate line, energy gate line. In this example, show the water flow from the tanks is gravity flow, and given that the set here is 3 meters. Okay, and we start to solve the velocity head from this gravity flow by assume that by using energy equation between point 1 and point 2. Point 1 and point 2. Point 1 is here in the surface, and point 2 at the outlet. Okay. So we start to write the equation of the pressure at the point 1 and point 2, and P1 and equal to P2 because equal to PATM. Atmospheric pressure, we can cancel the P is equal, and the next for V1 is very small because of this. Assume that it's a big tank, velocity is very small, so V1 is cancelled. So once we input number, we got an equation 1. Okay. And next we apply the quantity equation, because above equation we have V1 and V2, V and V2. So we find the relationship between V2 and V. Okay, and substitute equation 2 in equation 1. And finally we can estimate what is the velocity head. V square over 2g is about 0.554. Okay, next step, we apply energy equation from reservoir to point A. Okay, point A, that is the immediately under the pipe. So it is so this on the right hand side is the energy at point in the reservoir. Okay, and we can write the energy gate line for the point A is equal to, it's just the set subtract K minus loss. Okay, so we loss is about 22.17. so we can write is we can plot and write the number in here is the 22.17, somewhere here. Okay. Next we add the velocity head that from previous solution we got 22.72. So this number is 22.72. Okay. So finish at point A. So we do further to between energy equation between the reservoir to point B before the gauge valve. Before the for the gate. Okay. So from this we can find the gate line as point B is equal to 20.4. I mean we have to add minor loss and add axis entrance minor loss and the major loss for 24 meter. So we got 20.40. Okay, from this and add velocity head, we got 20.95. Okay, so we passing through points across the hydraulic gate line across the valve. So the energy loss dropped by minor loss about 5.54. So we just subtract the hydraulic gate line to got the 15.86 and hydraulic gate line energy gate line is 15.41. Okay, we do further to point D from reservoir to point D. Okay, and we add another major loss. So we have 24 and 36 meter. So we prove that the hydraulic gate line at this point is 12.75. Yes, and the rest you can do by yourself to finish to plot the profile of the hydraulic gate line, energy gate line for this problem.